Hello, this is Greg French. Welcome back. Today we're going to be covering Chapter 5, Part 3 in our A+ computer repair series, CPUs and chipsets. The chipset, set of chips on the motherboard, controls the memory cache, external buses, and peripherals. Intel dominates the market for the chipsets. Reason they dominate, they also dominate the CPUs or the processors, and they've also gotten into the motherboard manufacturing and consequently have kind of a domination now of the chipsets. Example is the i800 series of chipsets, some of their newer ones. Intel 800, they're also in the 900s now, series accelerated hub architecture. All I/O buses connect to a hub interface. The hub connects to the system bus. North Bridge contains graphics and the memory controller. I'm going to talk more about the North Bridge, a very important chip. That's really what determines the performance for your computer, because it will maintain the bus speed that the CPU runs at. Also, it connects both the RAM and the video card to the CPU. The faster we can get the RAM to run, the better the performance of the computer. And we don't want a bottleneck on the video side, so we need to be able to run data in and out of our video card very, very quickly. The South Bridge, that will take care of everything else. Hard drives, keyboard, mice, the PCI slots from the motherboard, everything else. Here's a good diagram showing the CPU at the top up here. Here we have our system bus, which connects to our North Bridge. Now, the North Bridge is also called the memory controller or hub. And then we also have the South Bridge down here, which is called the I/O controller, and it connects your motherboard, PCI buses, and hard drives, USB, everything else. But then up here, your North Bridge, this is what connects the RAM and your video card. This is really the heart of the performance of your computer. We need a good CPU, fast bus speed, fast memory, and a fast video card. Heat sinks and controlling fans. The controlling assembly should keep the temperatures less than 185 degrees Fahrenheit, which would be very warm. Target temperatures range only from about 90 to 100 degrees Fahrenheit. One or more fans are usually needed to meet these cooling needs. You'll have a fan directly on top of the CPU, but you'll also have a case fan that'll help pull that hot air out of the case. Cooling fan sits on top of the processor with a wire or clip. Heat sink, clip-on device pulling the heat directly from the processor. Heat sinks generally have some kind of material that helps to transfer that heat directly from the processor to the heat sink. Sometimes it's a paste. The paste has a silver powder in it, and the silver is a very good conductor of heat. Cooler, a combination of heatsink and cooling fan. Depending on the processor and depending on maybe if you're going to overclock, these can get quite elaborate. They do have liquid cooling devices that can really bring the temperature down quite a bit on these CPUs. Gets a little expensive though for an overclocking type of heat transfer. Here is the older slot 1. You can see the big heatsink right here, and then the fan. The fan will help blow the heat off the heatsink away from the CPU and get the CPU down as far as temperature. Processor controlling the fan mounts on top of the side or the side of the processor housing and is powered by an electrical connection on the motherboard. Today, even the power for the fan here is controlled by the computer depending on the temperature, so the fan is regulated in speed. Installing a processor. Types of installation. Technicians are asked to perform assembly a PC from parts, exchange a processor that is faulty, or maybe upgrade, add a second processor to a dual processing system, or upgrade an existing processor to improve the performance. Motherboard and documentation lists suitability of these processors. So you always need to look at the motherboard, see what CPUs or processors that it can handle. Some processor features to consider. Looking at core frequency is always very important. Also your bus speed. Bus speed is really an overriding factor of even the core frequencies. Faster the bus speed, the faster we get that data in and out of the CPU. Multiprocessing capabilities, very important, and also an appropriate cooler. Voltage to the processor. Earlier processors drew power from the system bus lines. The newer motherboards may have a power connector, and they all generally do now. There's a 12-volt connector that connects to the motherboard for power for the CPU. Modern motherboards relegate voltage in the socket. Sockets were more universal for older processors. Processor may fit the socket but not get a correct voltage. Ensure that the motherboard supports the older processors. Dual voltage processors. Voltages for internal and external operations differ. And all the processors today have dual voltages. We have one voltage, which is our external voltage, which allows it to interact with the rest of the computer. But the internal voltages on the processor are extremely low today. As the processor gets more and more transistors, they've come up with newer types of processing or creation of these processors, which makes them smaller and smaller. The advantages as they reduce the size is the voltages get smaller, so there's less heat. Huge advantage. So we can make these processors extremely small today. Single voltage processor requires only one voltage. That would be a fairly old technology to have a single voltage. Here's that connection. You see right back here we've got a yellow and a black wire. The yellow is our 12 volt. Black would be the return. And this is the newer type Pentium 4, but all the newer processors today have this extra connection. Auxiliary 4-pin power cord from the power supply to the 12 volt on the board. CPU voltage regulator. Voltages could be set on some older motherboards, enabling motherboards to support various types of CPUs and voltages. Ways to configure the voltage on the older motherboards: there was jumpers generally. Uses a voltage regulator, VRM, can be embedded or installed with upgrades. In review, chipsets again. Chipsets have improved considerably as the CPUs improve. We have to come up with newer chipsets. Intel still has the memory controller in the North Bridge. They like to keep it in the North Bridge. That allows them to have a little more flexibility on the type of memory that can be added to the motherboard. Again, the performance of the computer really stands on that North Bridge. We need to be able to have a fast front side bus to the CPU, and it has to be able to support fast memory and a fast video card. Cooling, heat sinks and fans, very important, especially if we're going to overclock a CPU. There's some really fancy types of cooling that can be done to really get the temperature down. Installing the installation of the CPUs, very critical, especially with the new land grid array. It's easy to damage either the chip or the motherboard. And then the voltages. We talked a little bit about the voltages. Since the Pentium 4, there is a newer plug that now is plugged into the motherboard to allow the voltages for the CPU. And that has 2 yellow and 2 black wires providing 12 volts. Activities. I want you to research the chipsets and also want you to diagram those connections and operations and be able to discuss. You need to be able to kind of diagram this architecture, CPU, chipsets, North Bridge, South Bridge, what connects to them. If you can diagram that and explain that, that's pretty important so that you understand how a computer works and the importance of those chipsets. Lab 5.4 chipsets, I'm going to be able to do a little of this diagramming, understand a little bit more. Also, we have a quiz, CPU and chipsets. You'll find that on exam field I want you to complete. That's it for now.